In this video, I'm going to demonstrate how to create a manual tornado object in the Prototype Feed tool. To start, you have to click this red T button up in the upper left. These three buttons are all the manual drawing controls for the three hazard types: tornado, severe, and lightning. And so to do that, we click here, and then it tells you to click and drag on the map. Before you do that, it gives you some couple options for drawing. One is ellipse, the other is a regular polygon. The irregular polygon is probably better for the severe and lightning hazard types. The ellipse ends up being pretty good for tornado, so we'll stick with that. Then you just go over to the map, again click and drag, so it's good to start in the upper left corner of where you want to start dragging, and then drag down toward the lower right. You see this creates this blue polygon as I'm holding the click. And basically, once you get that set to where you kind of want it to be, then just release the click, and then that creates your initial object. And then from there, it uses the motion vector along with some motion uncertainty information to create this downstream swath that you see here. By default, the motion vector is set to 270 degrees at 32 knots, and so that can be overridden by typing and changing these values here, or you can do kind of like you do in WarnGen and just go back a few frames on the map and then click and drag the polygon, in this case instead of a point, to where you want it to go, and then return back to the current frame. And when you do that, then you'll get all your controls back on the left side. From there, then it's a matter of just filling out the options on the left side. So to start with, the product type is automatically set to warning for anything that is a manually created object, again using these buttons at the top. There's also an option for a sub-severe product that we label advisory. Below that then is the severity, and so we have a couple of tags that you can set. I know you cannot see the options here due to some screen recording limitations, but the three options include weak, short-lived, considerable, and catastrophic. And those, of course, then are patterned after the impact-based warnings paradigm that has recently been operationalized. So for this one, I'm going to pick considerable. For the source, we have three options: radar indicated, observed, and predicted. The predicted option might be good if you're using some one-on forecast information, but for now, I'm going to kind of skip that, and I'm just going to use the observed tag. Again, here's the motion vector information that can be overridden, and so let me just, for example, change this to say 20 knots, and you can see how that kind of changes a little bit of the stuff on the screen. I'll change this to say 250 degrees, and you can see how that kind of changes the orientation of the plume. So let me change this back to say 260. That's something that's maybe a little bit more accurate. And 25 knots. The duration value is automatically set to 60 minutes by default, and that's for all of the manual objects that get created. So that can obviously also be overridden. So from there, then below that are some options for the type of prediction and the forecast confidence. I'm going to skip the prediction option. It's kind of in depth, but just know that persistence is set by default. It ends up being sort of a good default to use when creating objects. The guidance section, for that, it's good to reference the training materials for that. So I'll go to the other tab here. Under guidance for tornado, we get this page, and if we scroll down, there is this SPC diagnostic tornado probabilities, and that is what we call the peak shear value in the tool. And so this is based on the VROT calculations done by the folks at SPC. What we use in the tool then is the EF0 line on this graph, and so this is showing the relationship between the peak rotational velocity and the probabilities associated with those based on their historical data set. So as one should expect, as you get higher peak inbound to outbound difference across the velocity couplet, as that goes up, you get higher probabilities of having a tornado. And so if we go over here, what we do, say we type 50 knots, that will then use that gray line as a lookup table, set that as the T0 value, and then assume a linear decay from that point on. And so if we change this to say 40 knots, you can see how those probabilities go down. The other option is prob tour. If you go back to the training and scroll up here, the prob tour values come from prob severe. So for that we have to go, this takes you over to the guidance for total severe. Then here it kind of shows you what the predictors are that are going into this. This is a machine learning algorithm that's just basically using these predictors to try to come up with a probability value. There is more information here if you click on this PowerPoint presentation. But in order for this to work, you need to have an underlying prob severe object on the map, and so that's what's stenciled out here. Whenever we go into an edit mode, those get sort of automatically semi-transparent, just to kind of help clear up the screen. If we click the button though, it's going to pull in the prob tour value associated with the object, and that's displayed if you click this checkbox down here. And then again, it'll set it to the T0 value and then assume a linear decay. Just for the purposes of this demonstration, I'm going to show you all these button options. The linear is, as no surprise, taking the first and last value and assuming a linear decay. So I could, for example, raise this up and put linear. EXP1 assumes more of a faster decay, EXP2 a slower decay. The bell option, you have to set a third knob in here, and it's recommended to kind of go up with that. So, and also this little warning pops up if you're in persistence mode and you have any knob that is forecast to increase at any moment within the trend. It's going to let you know that that's probably not a good option. So you want this curve to monotonically decrease if you're using a persistence option. So in this case, for example, if I set this and hit bell, I'd probably want to use more of an explicit option because I'm forecasting this to increase in intensity. So that just kind of shows you that. +5, -5 just raises and lowers the curve. And before I get to observations, I'm going to go back to this draw button. So the draw button works when you click this. You have to move the mouse over to the left side, making sure it doesn't cross over the graph. And basically you just have to slide it across the graph, and then it just figures out where the mouse went and then records that as a trend. So you don't have to click or anything, you just have to simply slide the mouse across. And then the last one is observe. So for any situation where you have observed severity level occurring, so if that's 1-inch hail, 60-mile-per-hour wind, or a tornado, for example, it's probably recommended to use this observe button. And what that does will set the T0 value to 100%, meaning that basically it's occurring, and then I'll have that, it has it basically drop off as a function of time. Of course, you can use the other buttons then to override that. Last option is to simply take the knob and move it with the mouse. So you can create all kinds of stuff with that, and really go crazy with that. So for now, I'm just going to switch it back to the observed one. And the last thing then is to type up a discussion. And our users have really found a lot of value with this discussion box in terms of their decision making. And so this is an opportunity for a forecaster to express their raw thoughts on the situation. So things like observations, forecast intensity changes, if it's going to intensify, decay, maintain strength, any kind of information that you think could be helpful ends up being pretty helpful for the user generally. So anything that you can type here. So I'm just going to type something really simple and say, tornado occurring at this time. Last thing then is to hit issue, and you get a pop-up and say OK. And then from there, what that will do is submit the information to the server, and then you will see the swath disappear, and you'll get the object on the map labeled with your username. So in this case, I use my last name, the object ID number 1, and then in this case we have a P1. P stands for persistence. If it was the other type of prediction option called explicit, it would be an E1. 1 is the level of automation. If we go back to our training, just quickly touch, we have 4 levels of automation spanning from complete manual creation all the way to total automation with some human-machine mix in the middle. So because this was a purely manually created object, it's a level 1. The other objects you see here are labeled P4, meaning that they're completely automated. Below that is the diagnostic percentage value assigned to the object, so it's 100%. And the last label then is the how many minutes ago that you updated that object. So in this case, I just issued it, so it's set to 0 minutes. And so this can be helpful for sort of triaging the entire area that you're responsible for as a function of time. From there, it was assigned a warning, so later on I'll show a video that will kind of show what this will look like then once we get some warning information in there. But that's all rendered from the grid, which can take a little bit of time to appear. So the object information is all instantaneous, but the gridded information and the polygons that fall out from that, those take up to a minute or two to generate. So that's all for now.